Okay, so here's what I want to talk a little about. I want to give you my favorite example to kind of show this idea of omitted variable bias, okay? And hopefully give you a bit of intuition on how that comes about and talk a little bit about the graphs that Jordi mentions in his lectures. So let's look at the intuition. Here's my favorite example. Imagine that I give you unlimited money and I tell you, do the following task. Go to every seaside resort that you could find, and I want you to measure at any point in time for any given day how many people went to swim. Okay? I want you to measure how many people died of drowning, and I want you to measure how many people consumed ice cream and at what levels. Right? So go to all the shops of ice cream shops, right? Get their sales numbers. Go to the seaside, look at the number of people that are drowning at sea, maybe extra take also the number of people that are actually at sea or swimming at sea during those days. And imagine that here you had consumption of ice cream, and here you had drowning at sea, so number of people drowning at sea, number of drownings at sea. Okay? Now, let's say you did this and you spared really no expenses. You went to every seaside resort in the world. You did this study over 20 years. Okay? And what you found, without a doubt, was a data with lots of data points that looked like this. And chances are, if you do this, you'll actually find this. Okay? Consumption of ice cream is associated with drowning. And then maybe you hated ice cream when you were a little kid, and you said, here it is, I'm coming up with a story that really will convince everyone that they should follow what I think, right? So you kind of go and say, ice cream is bad for you, right? Ice cream kills you. And I have lots of evidence to show it, right? Philip, you're laughing. I mean, this is real data, right? This is serious business. People are dying, and they're eating ice cream, right? Is that changing your mind about eating ice cream?
No.
No. Why not?
I mean,
What if I told you this is real data, okay? And I told you that's what the smokers back in the 70s, they laughed at us scientists, right? Trying to establish a causal link between smoking and lung cancer. And then eventually they gave up.
It's not necessarily a causal link.
Okay, well, convince me. Just because you took MG205 and someone told you, correlation doesn't mean causation, doesn't mean that you could always kind of throw that thing out there and be like, well, it's just a correlation. I don't really care. It doesn't mean that it's causal, right? Effectively, that's what the tobacco industry did for a very long time, right? They just kept on throwing different things to tell that correlation doesn't mean causation, right? And smoking was so prevalent that there was a doctor that said, like, the probability that smoking is causing you cancer is like saying the probability that you're wearing socks is causing you cancer, right? Because everyone was doing it. Right? So it was very hard to kind of discern those things, right? But here you have some evidence. I promise you data will look like this. Should you stop eating ice cream just to be safe? Just to be safe. Well, it turns out that if you consume more ice cream, what does that tell you about the weather? It tells you that the weather is really good and it's hot. If the weather is hot, what does it tell you about the number of people that go swimming? It increases. If more people are swimming, what happens to the likelihood of more people drowning? It increases. In fact, this correlation here, you can show why the correlation doesn't imply causation if all of a sudden you controlled for the if you controlled for the temperature or the seasonality, or if you did something better. Imagine that you actually went and instead of doing ice cream consumption, remember I told you that you should not just collect the number of people that are dying, but you should also collect the number of people that are swimming at sea. So imagine that you did this number of deaths over people swimming. So now what do you have? Now you have probability of deaths. because of swimming, right? Now let's look at ice cream consumption over time. And probability of death perhaps will be flat. So that ice cream consumption actually is not really affecting your probability of dying or not. So you could freely go on and eat ice cream, right? Good news. Even though there is reasons to believe that sugar is also quite bad for you as well. So you might want to consider that aspect as well. And it's legal, right? You can have as much sugar as you want, right? There's no legal precaution. Right, so let's talk about omitted variable bias. What's happening here? What's happening here? Let's talk about regressions. Well, what's happening here is that you have a y variable, alpha plus beta, you have some x variable, which is your ice cream consumption, death at sea, and you have an error term. But this error term has temperature in that. Maybe some gamma times temperature or number of people swimming, right? And some other things that affect that, right? So what's going on here is that temperature or number of people swimming is positively correlated with ice cream consumption. Okay? Think of this as, actually, I'm going to think of this as number of people swimming. Big N. Number of people swimming. Okay? So there's a positive relationship between these two. And there is a positive relationship between number of people swimming and death that I see. So this gamma here is also positive. What does that mean? That every time I eat ice cream and I do this relationship, the consumption of ice cream is affecting the number of deaths through beta, but it's also affecting the number of deaths through gamma by the relationship of x with n. So there's a direct effect beta, which should be 0, and there's a direct effect which is showing up by virtue of the fact that more ice cream consumption simply means more people are swimming, right? Which is what's showing you that higher deaths. This, guys, is my favorite example of showing omitted variable bias, right? And it's also a very good example, Philip, to kind of convince someone where correlation doesn't mean causation, right? Because you can really show how these two things kind of go hand in hand with each other, right? So, and I can give you also examples from the medical profession, right? So, for example, I can't remember exactly the type of drug, but there was one drug that was being used in a particular section, and it gave a reduction in some heart disease, whatever, right? And then later on, they realized that the drug was very expensive, so the people that were buying these drugs were generally very wealthy. So the drug wasn't doing anything. It was just signaling that you were fairly wealthy and you could take care of yourself, right? So fairly wealthy people had less disease than not so wealthy people. So here's a failure of science in some way, because you look at these correlations and you don't find anything. Here's another one, which is a favorite of mine, which I probably talked about at some point. There was a study, a one-page study, which I can show you, which I will show you. There was a one-page study that showed up in a fairly respectable journal that talk about myopia and ambient light. Right? Here's what the study did. They look at different kids in the age of 0 to 18, okay, and they ask the parents, okay, when the kid sleeps, do you turn the light on or do you turn the light off? Right? What do you do? And we found out that when the kid was sleeping in darkness, only 9% of them had myopia. When the kid was sleeping in nightlight, 31% of them had myopia. When the kid was sleeping in room night, 48% of them had myopia, short-sightedness. Okay, developed short-sightedness of some sort. So here's these very reputable doctors, right? They come from Children's Hospital of Philadelphia, all sorts of things get published into it, and they even give you a theory. They tell you what might be causing that myopia, okay? I don't understand half the words that are in here, but they sound very authoritative, right? So if you kind of scroll through it a little bit and just read that for a second, right? It sounds like they have a theory of what might be causing myopia through the exposure of light at night. But that's what they have. Of course, they come kind of clean a little bit by saying, although it does not establish a causal link, the statistical strength of the association thus suggests that the absence of a daily period of darkness due to the early childhood is a potential precipitating factor in the development of myopia. So you hear this, what do? You make sure that your kid is sleeping in darkness, right? So this is scientific, right? These people wrote an article, they believed it, they came up with a theory, they went on and published it. Now what should we do when we observe something like this? Christina, do you have any explanation for this? What might be causing this? Are you going to make sure that, kids are falling asleep in a dark night? What's causing it? Philip, are you going to throw out the argument that correlation doesn't mean causation, or are you going to trust these very reputable professors? What are you going to do? Well, you're taking MG205. You keep on asking some questions, right? What are some good questions that you could ask here? Anna, what are some good questions that you can ask?
Maybe it's reverse causality, so that those kids who have myopia prefers to sleep.
Do you think like a 6-month-old kid has a say on that measure?
Not 6 months, but
Yeah.
maybe 3 years old.
So this study was between 0 to 18 months, okay? So these kids had no say, all right? So reverse causality is out of the question, okay? But it's a good try. What would you do?
No idea.
Are you pleased with these studies, and do you judge these professors or the judgments call that they've done? I mean, look at this yellow line. It seems fairly convincing, right? I mean, we go from 9% to 50%. Yeah, Jay?
Oh, sorry, it was a percentage. Does
If-
the end matter?
The end, sure, the end matters, so we can comment a little bit on the end. So it seems like most of the families leave a little nightlight for the kid, right? The end is relatively smaller here, but still fairly large, okay? It's not tiny, right? What is it? What should we do? What kind of questions can we ask, right? Should we trust the professionals for everything they write or they say? Well, we should trust them until proven otherwise. Here's the beauty of this. So let's go back to the ice cream example and let's link it back to this. Here's what it turns out to be. Myopia is a very genetic disease. If your parents have it, you are very likely to have it. Now let's go back to that. Myopia is short-sightedness. What does it mean? You cannot see very well. So if you cannot see very well, and you have a 0 to 18-year-old child to take care of, what do? You keep the light on. What do you do to the intensity of the light depending on your myopia? The more intense is your myopia, the stronger light you want. The more intense your myopia is, the more likely it is that your kids will have it. Mystery solved. It wasn't the light that was doing it. The light was just a confounder. The light, just like that ice cream consumption, was only there to signal that the parents had that particular condition. Right? So it wasn't the light causing it. It was the light being correlated with it because of this confounding. But understanding this is very powerful. Understanding this type of question and truly grasping that concept of correlation does not mean causation is very powerful, because it makes you very skeptical when something like this is given. And you don't take those things at face value. Right, so that's the idea of well, we talked a little bit about this intuition of omitted variable bias, right? And this omitted variable bias will not give us this idea of causality, precisely because of this. And of course, the graphs are easy to show once you grasp that. For example, in this case here, if you fixed the seasonality, or if you fix the temperature, or if you fix the number of people swimming, right, into these smaller boxes, you'd have realized that within those smaller boxes, ice cream consumption doesn't seem to have much of an effect. Okay? Doesn't seem to have much of an effect. Now, graphically, what you see in your lectures is something that looks more like this. So, for example, in the ice cream consumption case, right, your data looks like this. This is the thing that you estimate, right? But the true relationship, the true causal relationship should be flat, so ice cream consumption should have nothing to do with it. So let's look at a little bit on this econometrically. What do we know if this is x? What do we know about the expected value of epsilon conditional on x? What do we know about the expected value of epsilon conditional on x? Well, we know that the larger x is, meaning the higher the ice cream consumption is, the higher will be the number of people swimming at sea, which means that the relationship between x and epsilon is a positive one, meaning that expected value of epsilon conditional on x, right? This bit here, when x is large enough, right? So x is above the average, x bar, this thing here will be positive. And the expected value of epsilon, when x is below its average, this relationship will be negative. And those two things kind of balance each other out. So by noting down what's the relationship of the epsilon conditional on x, we see a violation of assumption 5. This violation of assumption 5 leads to different forms of biases. Okay? So in short, when you have an omitted variable bias problem, in the simple linear regression, you're also able to sign the bias. Okay, you're also able to sign the bias. Yeah. Okay. Fine. So I will end this here and take any questions.